Hello everyone, welcome to this tutorial. In this one, we are going to look into what sorting is and we are going to look at a very simple algorithm called bubble sort. So let's get started with it. Now, looking at sorting. So by definition, it is the process of arranging data in a particular order, right? It could be ascending or descending. Like in this example, if we look at the array, it's 3, 4, 5, 2, 1. And then after the sorting, it becomes 1, 2, 3, 4, 5. Now, you may ask, why do we need sorting, right? So it is used in few things, right? One could be searching. If we are doing linear search, its time complexity is O of n. But if we go for sorted array or if we have the sorted list, we can use binary search and its time complexity would be reduced. So it is helpful in searching. Other example could be finding the duplicates. If the array is sorted, we can look at the adjacent elements and find out whether the element is duplicate or not. One more example could be finding the median value. If the array is already sorted, we can easily find the median value. Now coming to bubble sort, what bubble sort is, right? So by looking at the definition, it is a very simple algorithm also known as sinking sort. In this one, what we do is we compare adjacent pair of elements and swap it if they are in the wrong order. So let's look at it, how it works by looking at the few examples. Let's look at one example where we have a list, let's say 2, 3, 1, 5, and 4. Now what bubble sort does is it does the comparison of adjacent elements one by one and then swap it. So if we look at the first iteration, in the first iteration, what it will do is it will start with 2 and 3. Now, if we look at 2 and 3, 3 is greater, so it's already sorted, it will do nothing. Next, it will compare 3 and 1. Now, 1 is smaller, so what it will do is this will remain as it is. In the next iteration, this 3 would be removed, 1 would be in place of 3, and then 3. So these two are swapped. Now again 3 and 5 are compared. Now since 5 is greater, it won't do anything. Next, it would compare 5 and 4. Since 4 is smaller, it would again swap. So my list after the first iteration would come out to be 2, 1, 3, 4, and 5. Now if we look at this one, after the first iteration, my largest element is at the end place because we are currently doing ascending order, right? If you want to descending and we can do it reverse way as well. Now, similarly, after the second iteration, this element is already there. So if we compare in the second iteration 2, 1, so it would come out to be 1, 2, 3, 4, and 5. So we can say that after the second iteration, my list would be sorted, but in normal scenario, this won't happen. We'll have to go through the list. Now, in case of logic, or how do we implement this? So logic wise, let's say I have a list, let's say 1, 3, 2, 4, and 5. So there are n elements. So we have to loop over this list. Let's say I'll do one iteration. Let's say this one, and then again I have to do one more iteration, because what it would do is in the first iteration it would compare these elements. So after one iteration this would be at the last, then after second iteration second largest element, then after third iteration. So in that way I have to do n-1 iterations to sort this. In the best case scenario, if the list is already sorted, then I have to do one iteration at least to check whether the list is sorted or not. Now let's look at the actual functioning, how it works. Now, if I want to code it, how would I do it? So let's start with the coding part. So let me define the function name or bubble sort. What I can do is I can pass on the array, let's say as elements. Now, as I mentioned, I have to do two iterations or two loops. So initially what we can do is we can set the size, which would be the length of the elements. Now I can use one for loop first for the outer part. Because remember, we have to do n minus 1 iteration. So we'll do size minus 1. This is the outer iteration. Then we'll do inner iteration. And I can define one variable called swapped is equal to false. This would help us when the list is already sorted. So in that case, we do not have to iterate through all the elements. After the first iteration, we'll get to know that the list is already sorted. So we do not have to loop over it and we'll break out of the loop. Now for the second iteration, what we can do is, let's say for j in range, size minus 1 minus I. So because after each iteration, we have to do that many less iterations, right? For the outer circle, because after one iteration, highest element is at the last place. So I do not have to go till far. I have to go n minus 1. After second iteration, I have to go till n minus 2 and so on. That's why we are doing size minus 1 minus I. Now, in this one, what we can do is we can add a condition if elements of j is greater than elements of j plus 1. Basically, if the next element is higher, then what we need to do. So in that case, what we can do is we can swap the elements, correct? So the simplest way to swap in Python is, I'll just simply copy this. We can swap the elements using this is equal to j plus 1, comma. So in that way, it will be swapped. And once those are swapped, that means we know that the elements are not sorted. So we'll update the variable swapped to true. Now, after this iteration, what we need to do is we need to add a check if not swapped. So what if it is not swapped? The list is already sorted. So in that case, we can break out of the loop. So this thing we can do. Now let me show you with an example how we can do it. Now let's suppose the list is 1, 3, 2, 5, and 4. Now in this one, number of elements are 5. So my size would be 5, correct? So for I in range, 5 minus 1, 4. So remember, this range, what it will do is it will skip the last value. So it will run for 0, 1, 2, 3. So it will run for 4 index. We do not need the last index because it will automatically be swapped. Then for j in range, size minus 1 minus I. So in the first iteration, the I is 0. So it will run till again 4. That would be 0, 1, 2, and 3. Now if we look at the first iteration, what it will do is elements of j greater than j plus 1. So it will compare these two values. So this condition would come out to be false. So it will go for the next run. Now 1. So it will compare these two. So 3 is greater than 2. So in that case, it will swap these elements. So it would come out to be 1, 2, 3. Right? And since these are swapped, this value would come out to be true. Okay. So in that way, it will go after each iteration, it would run. And if you check it, see, after each value swapped is equal to false. And if those are sorted, then only swapped is equal to true. So after first iteration, it would come out to be like this. So after first iteration, the list is sorted. So when it will run for the second time, in that case, it will break out of this because the list is already sorted. Now let's take an example of it. So let me take the array. This is already sorted. So let's take an unsorted one, 5, 4, 1, 2, 3. Now let's do bubble sort and elements. So let me print out elements. Initial value of elements was 5, 4, 1, 2, 3. After this bubble sort, it is sorted. And if we look at the time complexity for bubble sort, the time complexity would be O of n square. Why? Because we are going through two iterations. In the worst case scenario, we are doing two loops. So size n and n. So it would come out to be n square. And in the best case scenario, it would come out to be O of n because we are doing only one iteration. We are mentioning for loop for the whole n size. But in the best case scenario, we'll break out of it after the first iteration. So in that case, it would be O of n. And if we talk about the space complexity, it would come out to be O of one constant space because we are not taking extra elements. We are doing in-place iterations. And these swapped value and these are temporary variables. These are constant variables. We are not taking any extra space. Right? So that's why space complexity would come out to be O of one. So I hope you understood the topic. Thank you.